Until now, in all the examples, we have used only the basic gate, the first three gates and, or, not. Now onwards, we will try to see the equations where we have to use NAND gate and NOR gate. That means derived gate also. So in the first example, we have y is equal to a plus b whole bar. See, it is different from this a plus b bar. In this example, we have individual bar over the variables, so we use NOT gate. But in this case, we have a plus b. This entire expression has been complemented. And what is plus? Plus means OR operation, and if OR is complemented, it becomes NOR. As I've already told you while explaining NAND gate and NOR gate, how NAND gate is designed, why it is called as derived gate, because it is AND followed by NOT. It is designed by using basic gate. Similarly, what is NOR? It is OR followed by NOT, and what NOT gate does in both the cases, it complements. So OR complement is NOR and complemented is NAND. So in this case, it is a plus b whole bar, which indicates that it is NOR gate. That means you have to write a and b as two variables, and these two variable a and b is connected by plus, and which has been complemented. Plus has been complemented. That means OR gate is complemented. So which will be the NOR gate. And similarly, the next variable is a bar. So you take one a, individual complement is there, so you use NOT gate, so this becomes a bar. This is a plus b whole bar. And how these two will be connected? These two expression, this is the a first expression, this is the b second expression. How these two expressions are connected? By a dot sign. Dot sign indicates AND operation. So this is d and this is output y. So this is how you have to use derived gate also. See, this same circuit can be designed like this. If you can say a plus b, suppose if you design a plus b and then you complement it, so it will be NOT gate. So this is nothing but a plus b, and complementing it will give you a plus b whole bar. But what you are doing is, in this design you are using two gates, and the same thing can be drawn like this. You are using only one gate. So you have to make sure that when you design a logic circuit, you have to use minimum number of gates. So we are done with the logic circuit part and the truth table. See, truth table, you have only two variables, a, b, and the third variable will be a bar. The first expression will be a plus b whole bar. Instead of writing directly a plus b whole bar, we can write a plus b. In the next column, we will write a plus b whole bar. So it becomes very easy for you to write the truth table. And then y. So how many possible combination of a and b? 4, 0, 0, 0, 1, 1, 0, 1, 1. What is a bar? A bar is complement of a, 1, 1, 0, 0. A plus b, what is a plus b? A plus b means between these two columns you have to perform addition or operation. And in OR operation, what is OR operation? If any one of the input is 1, the output will be 1. When both the inputs are 0, the output will be 0. It amounts for addition. 0 plus 1, 0 plus 1, 1, 1 plus 0, 1, 1 plus 0, 1. So a plus b will 0 plus 0, this is 0 plus 0, 0, 0 plus 1, 1, 1 plus 0, 1, 1 plus 1, 1. And complement of a plus b will be the complement of this entire column. So entire column will be complemented. It will be 1, 0, 0, 0. And what is y? Y is AND operation between these two expressions. So we have already got a plus b whole bar, and the next expression is a bar. Between these two columns you have to apply AND logic. AND logic amounts for multiplication. If any one of the input is 0, the output will be 0. When both the inputs are 1, the output will be 1. So 1 and 1, the output will be 1. 1 and 0, 0, 0 and 0, 0, 0 and 0, again 0. So output y is 1, 0, 0, 0 for this expression. For this example, y is equal to a plus b whole complement dot a bar. Next, on the same lines we will do for y equals to a bar dot b whole bar plus a. So again you start with this expression, this is a, this is b, these two is connected by OR gate, that will be at the last, and then this will be, first we will solve this, so a, b, and how a bar, this is a bar, so you have an individual bar over a variable, so you connect a NOT gate, b as it is, and how these two are connected, dot and over bar sign or a complement sign over it. So dot means and complete complement over and is and followed by NOT, which is NAND gate. So this is the symbolic representation which we have to use, dot whole bar. So this is the NAND gate. So what is the expression you get is a bar dot b whole bar. The next variable is a bar. Simply draw a line a, and how these two are connected, these two are connected by a plus sign. Plus sign indicates OR operation, so OR gate has to be drawn, which will give you output y. So this is the logic diagram for this equation. Next, truth table, again a, b, a bar dot b, a bar dot b whole bar, and y. So again 0 0 0 1 1 0 1 1. A bar is complement of a, 1 1 0 0. What will be a bar dot b? A bar dot b means between these two columns you have to apply AND logic. And what is AND logic? AND logic amounts for multiplication. So 0 into 1 0, 1 into 1 1, 0 0. Complement, the whole complement of a bar dot b will be the complement of this, it will be 1 0 1 1. And what is y? Y is OR operation between these two expressions. So we have got this, and the other expression is a. Between these two columns you have to apply OR logic. OR logic amounts for addition. If any one of the input is 1, the output will be 1. If both the inputs are 0, the output will be 0. So it will be 0 plus 1 1, 0 plus 0 0, 1 plus 1 1, 1 plus 1 1. So this is the output for an equation y is equal to a bar dot b whole bar plus a. Let us increase the level of the equation a little bit. Let us make it a little bit more difficult. Now let us try to design these two circuits. The first one will be a bar plus b bar whole bar. The variables has individual complement as well as these two are connected by a whole complement. So let's say this is a and this is b. So first you solve a. How to solve a? A is a, b, and how these a and b are connected? A and b are individually bars, so you have to use the complement. That means NOT gate to get the complement of that variable. So when a, this is a bar, b, this is b bar, and these two are connected by a plus sign and a whole complement over it. Plus sign indicates OR operation, whole complement of OR operation is NOR operation. So it will be connected by a NOR gate. So this will be a bar plus b bar whole bar. So you got one expression. Similarly, you solve the second one. You have a, you have b connected by again a plus sign and a bar sign whole complement over it. So it will be NOR operation. So this will be NOR gate, a plus b whole complement, and these two are connected by, how these two are connected? Connected by dot sign. Dot sign indicates AND operation. So this will be connected by an AND gate. So this is the logic circuit for this expression. The truth table will have a, b, a bar, b bar, a bar plus b bar, a bar plus b bar whole complement, then a plus b whole complement, and y. So again a and b, 0 0 0 1 1 0 1 1. what will be a bar? Complement of a, it will be 1 1 0 0. B bar, complement of b, 1 0 1 0. Next, a bar plus b bar, that means between these two columns you have to perform OR operation, OR amounts for addition. So 1 plus 1 1, 1 plus 0 1, 0 plus 1 1, 0 plus 0 0, and complement of this will be 0 0 0 1. So you got this one expression. Similarly, what is a plus b? A plus b is simple, you know already. OR logic, addition, 0 plus 0 0, 0 plus 1 1, 1 plus 0 1, 1 plus 1 1, and complement of that will be 1 0 0 0. Now what will be output y? Output y will be these two expression and connected by AND gate. AND gate amounts for multiplication, so it will be 0 multiplied by 1 will be 0 0 0 0. So output y will be 0 0 0 0 for equation y is equal to a bar plus b bar whole bar dot a plus b whole bar. I hope you have understood. Similarly, we will do the next problem. The next one, again this is expression a, this is expression b. First to solve expression a, this is a NOT gate, a bar. The second expression is b. How these two are connected? Dot and a bar sign over it, that means dot sign indicates and whole complement, that means it will be complement of AND gate, which is NAND gate. So this will be like this. Similarly, a dot b bar, that means a connected as it is, b will be connected by a NOT gate to get b bar. So a and b bar will be connected by again dot and a bar sign over it. So and followed by NOT will be NAND. So a dot b bar whole bar. We got both the expressions, and these two expressions is connected by a plus sign, that means OR gate. So this is the logic diagram for this equation. Truth table: a b, a bar, b bar, a bar dot b, a bar dot b whole bar, a dot b bar, a dot b bar whole bar, and output y. So again 0 0 0 1 1 0 1 1. What is a bar? 1 1 0 0, complement of a. What is b bar? Complement of b, 1 0 1 0. What is a bar dot b? AND logic between these two columns. AND logic is multiplication, so it will be 0 into 1 0, 1 into 1 1, 0 into 0 0, 1 into 0 will be 0. Complement of this will be 1 1 0 1 1. Similarly, a dot b bar, between these two columns you have to apply AND logic. 0 into 1 0, 0 into 0 0, 1 into 1 1, 1 into 0 0. Complement of this 1 1 0 1. And last, what is y? Y is expression, these two expression is connected by OR logic. So these two expression will be connected by OR gate, OR operation, and OR operation amounts for addition. If any one of the input is 1, the output will be 1. So 1 and 1 1, 0 and 1 1, 1 0 1, 1 and 1 1. So output y is 1 1 1 1 for y is equal to a bar dot b whole bar plus a dot b whole bar, a dot b bar whole bar. The next two example will again be a little bit more difficult, so that we can understand all types of logic equation which can come in exam. So the next one is a bar plus b whole complement, that this expression has been whole complemented, and then this is your A and this is your B, and these two expressions again has been whole complemented. So see carefully how I am executing the equation. So first we will solve A. So how we'll solve A and B are the two variables, and a bar sign over A. So A bar, B you have to keep it as it is, and how these two expressions are connected, plus and has been whole complemented. Plus matlab OR gate, whole complemented, or complemented is NOR. So you connect by a NOR gate. What is the next expression? This we have already achieved. Next is B, that is A. It is simple. B will be straight line from A. So this is your A bar plus B whole bar, and this is A. So you have got both A and B, and how A and B is connected? Dot and whole complement over it. Dot means and, complement over it indicates complement of AND is NAND. So it will be a NAND gate. So this is your output Y. So this is the logic circuit for Y is equal to A bar plus B whole bar dot A whole complemented. Next is the truth table part. So it will be A, B, A bar, then A bar plus B, then A bar plus B whole complemented. That means this expression, and then the output Y. First Y, what we have to do is, instead of that we will write A bar plus B whole bar dot A, and Y is complement of this. So Y will be A bar plus B dot A, this complement, whole complement. So it will be 0 0 0 1 1 0 1 1. A bar will be 1 1 0 0, and A bar plus B. A bar plus B means between these two columns we have to perform addition. So it will be 1 1 0 1. Complement of this will be 0 0 1 0. Then A bar plus B whole bar, that means this column and the first column, between these two you have to apply AND logic. So AND logic will be 0 0 0 0 0 0 again, 1 1 1 1 0 0 again, and then Y is the complement of this. So it will be 1 1 0 1. So this is your output for equation Y is equal to A bar plus B whole complement dot A whole complement. So Y is equal to A dot B. So first you take this as expression A, this is B, take this one, so it will be A and B connected by a NOT gate, which will give you B bar. So this is A and B bar. A and B bar is connected by dot over bar sign, and dot means AND gate, bar sign over it is complement of AND, which is NAND gate. So this will be A dot B bar whole bar. So you got expression A. Next expression is simply you draw A. So you got A and B both, and A and B is connected by a plus sign and a bar sign over it. Plus sign indicates OR operation, a bar sign over it is complement of OR, that is NOR. So this is the logic circuit for equation Y is equal to A dot B bar whole bar plus A whole bar. The truth table of this logic circuit can be written as A, B, B bar, then A, B, B bar, then we have A dot B bar, A dot B bar whole bar, then this expression A dot B bar plus A, and Y will be the whole complement of this, which will be whole complement of this, which will be A dot B bar whole bar plus A, the whole complement. So this will be A, B, 0 0 0 1 1 0 1 1. B bar will be 1 0 1 0. A dot B bar, that means AND logic between these two columns, AND logic amounts for multiplication. So 0 and 1, 0, 0 and 0, 0, 1 0. Sorry, the third column is 1 1, so 1 1 0 0, and complement of this will be 1 1 0 1. Now next is A dot B bar whole bar, this column plus this column, OR logic between this column, and OR logic amounts for addition. So it will be 0 plus 1 1, 0 plus 1 1, 1 plus 0 1, 1 plus 1 1, and the y will be the whole complement of this, so it will be 0 0 0 0. So this is how we have to design the logic circuit, write truth table using logic gates. This is very important. I hope you have understood.